And welcome again, everyone. My name is Steve Wilson. I work at the Illinois State Water Survey, and I manage the private well class. And I have with me Jennifer Wilson, who works at the Water Resources Center at the University of Illinois. And tonight we're going to go through the proper care of your private well, which is the second of 3 webinars. I'd like to recognize the Rural Community Assistance Partnership, RCAP, for their support for this program, and US EPA, who funded the development of this project. So tonight we're going to spend a few minutes talking about what the private well class is and what we're going to cover. And then for those of you who may not have used GoToWebinar before, a few logistics. And then when we're done, we'll sum things up and answer questions. What we've been doing is taking a few minute break so that folks can ask questions. And if you notice on the bottom, either under chat or under questions, you can ask questions through your GoToWebinar window, and at the end of the discussion, we'll try to go through those. Now, doing these at night, we're on our own. I don't have anyone else here as far as any of the other experts from the survey or other organizations to help me, and so I'll warn you now that if I can't answer a question, I'll probably ask you to email me the question, or we will post it on our website at a later date. So let's move forward. So the private well class, anyone who's on the webinar probably is already taking the class, but if not, if you go to the website, you can sign up. There's 10 lessons. It's self-paced. These webinars are meant to provide additional information and support those lessons. The lessons have more detail. They're emailed to you once a week, and so if you have not done that, please do, because that's where the real meat of the information is, if you will, and where you can find links to other resources that are free and available online that'll help you understand your well and your well system better. So yeah, if you haven't signed up for the class, please do. This is not the class per se. These are the webinars in support of the class. And at the bottom it says, don't worry, you can start anytime. If you are already taking the class, great. If you haven't, yeah, once you start, they're delivered once a week. And it's self-paced, so you're on your own to go through those lessons. This is the front page of the private well class, and there's a button here to click on to enroll if you want to take the class. It also lists here the sponsors. Again, the U of I and the Water Resources Center and the Water Survey are hosting this with funding through RCAP and US EPA. Down at the bottom, there's an email us with info@privatewellclass.org. If you have any questions that come up tonight or some other day, email us. We will try to find an answer. If we can't find an answer, we will contact someone in your area and try to help that way. Obviously, we're at Illinois in Champaign, and so we may not be the best person to answer a question in some other state or some other area, but we will try to help and do the legwork to get you in contact with the right person who can. And so that's kind of our job. When you sign up for the class, this is what you see. All we need is an email address. We ask for your first name and the state where you live. As far as the state or territory where you live, that information just helps us show our sponsor that we're reaching out to the entire country and all the territories, and that will help us gain future funding and improve what we've been working on with the class and those sorts of things. So we appreciate everyone who signed up. So the 10 lessons, quickly, it starts out talking about the science of groundwater, basically how groundwater flows, and we move through well construction, the different well types, then all the other information from your well into your house, your pumping, your pipes. Then once we've talked about the infrastructure for your system and how water gets into your water system to your tap, talk about O&M and best practices. O&M stands for operation and maintenance, things you need to do, which we'll cover some of that today. And then look at emergencies, failures, and problem solving. Again, we're in Illinois, and a lot of times there's some great information available. A lot of states and a lot of even local jurisdictions like counties or regional areas have folks who are experts who know your geology and your well types and your water quality issues because of the groundwater you have in your area. And so what we promote and try to impress on everyone is how important it is to know where your local resources are. And so we certainly devote some time to that. and it ends up with sampling and interpreting results in water treatment. It's kind of going from the very beginning to what you need to know in the end, so to speak. And it's fairly comprehensive, and we hope you enjoy it and understand it all. If you have questions, again, on any of the lessons, you can always email us. Tonight, this is the second of 3 webinars. We did one last Tuesday, and we'll do one next Tuesday. And this is on the proper care of your wells. It kind of covers lessons 4 through 7. Again, this is more of an overview. It's a fast version, so to speak, of the lessons that we provide. And it's as much to give people an opportunity to ask questions or to hear it in a different way than just reading it as it is anything else. So we are recording this, and honestly, this is the 3rd time we've given this webinar, and in the end on our website will be one of the 3 recordings for webinar 2, whichever one probably looks the best and sounds the best. And so, but there will be a version available, so down the road if someone wants to watch this over again or listen to it over again, they can, or if they want it, they share it with a neighbor or a stakeholder that they know, maybe a county extension or whatever, they can provide that information to them. If we can't answer the questions, as I said before, we will eventually put the answers and the questions on our website. We honestly haven't done a great job of that so far. We've been trying to get through the basics of the class, but that is the next thing on our list as far as providing updated information. And so we have questions from, this is the 8th webinar. It's the 3rd time through the 3 webinars. And so we do have a number of questions that we'll post, kind of a FAQ, if you will, of what's going on. And as far as tonight goes, you can see Jennifer put a welcome in the chat. There's also the question box. You can ask a question there. And when something comes up you don't understand, I would prefer if you only ask questions about the material we're covering today. Obviously, if you ask a question about something else, we're not going to tell you no. But there will be a webinar next week that deals with, more of the water quality and treatment and proper sampling result stuff and some of those things. Okay, so tonight we're going to start with correcting poor well construction. Almost every state has well construction codes and licenses drillers. And so over the past 30 years, those things have changed a lot. Now, existing wells have always been grandfathered in, I believe, in every state, but certainly in most states. And the only state without well construction codes is Pennsylvania. But many wells still exist in pits, and that's a big problem. They're a safety hazard. They're, originally before the advent of the pitless adapter, wells were put in pits in areas where there was frost and freezing in the winter so that the well was below the frost line. And now with the pitless adapter, your well can be extended to the surface, properly protected at the surface. Every time it rains, a pit can fill with water, run off into your pit. Those sorts of things are really a problem. And the other poor construction are hand-dug wells. And a large diameter dug or bored well uses water from near the surface. It infiltrates in. So today's construction codes, for instance in Illinois, for a bored well uses concrete tile, and the well really starts 10 feet below land surface. The upper 10 feet is protected. But many old hand-dug wells, which are basically a large bored well, go all the way to the surface. They're protected by sometimes a concrete pad, in some cases much less than that, and it's an opportunity for surface contamination. And so they're also, especially wells in pits, are a safety hazard, as well as dug and bored wells that have a cover that isn't solid and able to hold a lot of weight. And so they're a risk. Here's a couple examples. These both came, well, one of these is from Washington State Department of Ecology. They have a blog, and a woman fell to her death. The plywood they had over their well gave way when she walked over it. It had gotten rotten, and it killed her. And this other example here is a well in Manitoba. Their provincial government provided a little manual that we actually link to on our website that talks about, here's an old well that isn't properly constructed at the surface, and then there's an example of what it should look like in the end when this has been properly raised up and then sealed around the well. So The best thing to do if you have one of these types of wells is to bring it up to code. And you can contact your state, usually public health department, or in some cases it's a Department of Natural Resources, or it may be some, like in Washington State's Department of Ecology, that regulates well construction, and they can tell you what the code is today. And those codes have been updated over time to protect your well and the groundwater from contamination. So you use clay grout or some fairly impermeable type of material around the well. You extend the pipe above land surface, and you install a pitless adapter. And you should use a contractor to do this work for you. They're licensed, they're bonded. If you're using your well for drinking water especially, it's not something to try for the first time yourself. Here's two examples of, well, the well on the right is the finished well that we just looked at from Manitoba, where it was the corrugated pipe, the large 3-foot diameter corrugated pipe with the well in the middle. This is what it looks like now that they've properly constructed it, raised it to the surface, and used clay and soil material around the well to keep it from allowing water to pond and those sorts of things. The well on the left is a dug well, a hand-dug well at a farm in Illinois. I took this picture. It's a well in existence today, and they have 2x8 and 2x10 boards over it with some tin pieces and then concrete blocks to hold that in place. This obviously isn't the best situation. There's runoff from the field. This is a cow pasture, and there's infiltration right near the well. This is a brick-lined well that's not cemented. And so this sort of situation is where we find many of the water quality problems, especially bacteria issues in private wells. So moving on to your pump, how to protect your pump. Eventually your pump will wear out. It's a mechanical device. It's especially a submersible pump is underwater the entire time. It's sealed, but there are things you can do to help your pump last. And there are problems you might encounter with your pump if it cycles a lot, and I'll go through that in a little bit. But you need to maintain your system such that your pump doesn't run any more than it has to. So the first step in that is make sure it's properly sized. Sometimes you'll find that either your use has changed, now you bought a house in the country, it was a residential home with a well, maybe you've added livestock or a garden or some other thing where you're using a lot more water, then maybe your pressure tank isn't big enough, your pump is operating a lot more than it is meant to be. And so those things a contractor can help you with. You can determine what your use is, and if your pump and your pressure tank are properly sized. As far as protecting your pump from wear, beware of sediment issues. Sediment getting into your well, either through a screen or if it's a bedrock well, just through the cracks in the open space in the well, can cause more wear on your pump. If sand is getting through into your well from your screen, for instance, it can cause your pump to wear out a lot faster. It's abrasive, and one of the things to make sure of is that your pump intake isn't too close to the screen. Ideally, your pump intake for a sand and gravel well should be at least 5 to 10 feet above your screen, so that you're lowering the velocity that's coming through the screen at the bottom of your well. And so in some cases, wells can become plugged as far as the screen at the bottom, or cemented based on chemistry over time. And then you have preferential flow. There's not as many openings, so your well, the velocities of the water coming through the openings that are left are much higher, and they can pull sand into your well. And so if you start noticing sand in your faucet or in your bathtub or anywhere, and those sorts of things, you need to get that fixed right away and find out what the cause is. And again, you'd want to contact a licensed contractor to do that. Some common pump problems, rapid cycling of your pump. That very likely could be an issue with your bladder tank or your pressure tank. Today's pressure tanks have a bladder inside them. They're meant to last a long time. but sometimes a bladder can get a crack or a hole in it. And the whole idea behind a pressure tank is that you have a bladder full of air, and when you pump water into your pressure tank, it's compressing that bladder of air, which increases the pressure as you lower the volume. And so then whenever you need water, you turn on a faucet, the pressure of the air in the bladder pushes water through your system to your faucet. And when you start seeing cycling of the pump, or if it runs excessively, a lot of times that's because there's either a leak, and so your pressure tank isn't working properly, or your bladder has become fouled with water in it. And if you have an old pressure tank that uses air directly with water, those typically get waterlogged, where the air dissolves in the water, and eventually you lose the volume of water that you have in your pressure tank, and so then your pump will just cycle on and off fairly constantly. And if you have a deeper well with a submersible pump, it'll be hard to notice that because you won't hear it, but you might notice higher energy costs, or your energy costs going up, and that might be an indication. Hopefully, if you have a shallower well where your pump may be in your basement, or it's close enough that you can tell it's pumping more than it should, then that's an indication that you need to have it serviced. If your breaker trips, that can mean that there's a short, and or that also if your pump won't come on at all, then there's likely been a short in the line. If it's a submersible pump especially, this just means it's probably wore out, or somehow the electric line has gotten water in it. So those are typical issues that you have with your pump. So low-yielding wells. In some areas of the country, like in Pennsylvania, there's areas where it's a bedrock aquifer. It's very low yielding, which means it only pumps a few gallons a minute. This is a problem whenever you're using a lot of water, like for a shower or washing dishes or any other high consumptive use. So in those cases, a lot of times your pump needs to be the appropriate size, which means not too large, because pumping a lot of water in a low-yielding well means your well will draw down very fast. So your water level may be 40 feet below land surface and your pump's at 100 feet. You could draw it down to the pump very quickly if it's a low-yielding well and your pump is pumping a lot. And so what that can do then is if your pump is out of the water, it'll burn up because the water is what keeps it cool. And so in those cases, it also breaks suction is the term, where it's pumping some air with water because you've lowered the water level down to the intake. And one way which decreases the pressure in your line going up to your house and to your pressure tank. And one way to deal with that is a low pressure cutoff switch, and that'll protect your pump from running excessively when the water level drops below the intake, and it'll keep you from burning up your pump. Now, as far as a low-yielding well goes, your best option typically is to have a larger pressure tank. Because your well can't pump that much water for a very long period of time, you want your well to fill up your pressure tank and have a larger pressure tank with more volume so that you have more use from your tank rather than your well. You want to have your pump working when you're not using water. And so a large pressure tank is a lot of times the best solution there. That would mean, during the night when everyone's sleeping, those sorts of things. Yeah. So other yield issues or other low yield well issues, these wells are just problematic. And even if you have a large pressure tank, there's other issues. When you pump a well with a low yield, you're drawing down more water in the well. And if it's a bedrock well especially, you can change the chemistry, because the rock that makes up the casing of your well is underwater. It's got one type of chemistry. When you lower that water level and that rock's exposed to air, sometimes that it causes oxidizing conditions that can release metals like arsenic or lead, and those things then can precipitate out and cause a lot of buildup and sediment problems down the road as they continue, as that chemical process continues in your well. So it's also a better environment for biofilm growth because you're providing air it used to be believed that there weren't bacteria below the soil zone. And now we know and have known for about 40 years that bacteria are ubiquitous everywhere. You find them in groundwater, deep groundwater, in conditions where nothing else will live. Scientists find bacteria. And so those aren't always harmful. So, certain kinds are harmless. We have things like there are certain kinds of bacteria that just exist in groundwater that we drink every day that aren't harmful. And so it's just something to be concerned about. And again, I mentioned the Pennsylvania well. I was at a presentation in Ohio last year where a gentleman spoke about the chemistry changes in a private well in Pennsylvania. And they had sampled throughout the day where they had been using the well, and it was really low yielding, like a half a gallon to a gallon a minute. And so when this well kicked on, or the pump kicked on, the water level dropped, I think, 75 to 100 feet in the well. And they collected water samples throughout that process in a short time to see how that changed over time throughout the day. And what they found is, one sample doesn't really tell you in those situations what your water quality is. There was a range of water quality values for different parameters with time, depending on what the water level was and how long the water had sat in the well. And so there's some significant things that implies. For instance, in Pennsylvania there are fracking issues, and because there's a lot of fracking that goes on there, and so to understand your chemistry and protect yourself, you may need to collect more than one sample, for instance, is a take-home message there. So, pressure tanks. I mentioned earlier most pressure tanks today are bladder tanks, and they require very little maintenance. They last a long time. It's a kind of a rubber-based bladder that's inside there full of air, and as you pump water in, the bladder gets compressed. That increases the pressure, and that pressure in the tank is what pushes water through your faucet and out into for your shower and everything else. And so if you have an older tank where air is in contact with the water, you need to check it more frequently. Again, it can cycle your pump. There are cases where whenever water goes into your pressure tank, especially an air-connected tank where it's air in contact with water, if there are gases in your water, they may come out of solution. And in some cases, even those gases have to be vented. And there's a process for that. You need to talk to a contractor if you have any of those issues. If you ever turn on your faucet and you have spurting water or methane, it can be annoying, and it's something you need to get taken care of. So the other thing that can happen if your pump, for some reason, a switch goes bad, or for some other reason your pump won't shut off, it's good to have a pressure release valve on or at your pressure tank to keep it from getting overpressurized if there's a problem with your pump not shutting off, which is a rare occurrence, but it's just something to understand. So as far as best practices, there are a lot of things you can do as a well owner to be a better steward of your water system and your well. One is just to understand where your water comes from and some of the things that we talked about in the last webinar, but also keeping good records and maintaining a file system is really critical for anytime you have a problem. So accurate records, who did what work on what piece, if you have a different contractor for your pump versus who drilled your well. They're all supposed to be bonded and licensed. And so, your well and your water system is a huge investment. And so you need to protect that. You're your own steward for your water system. Folks that live in a community, they just have to worry about turning on their faucet and paying their water bill. And having a private well is a much different endeavor. So knowing the type of equipment, all those things will help you and your contractor. So let's say it's been 10 years and you have a well problem. The contractor you used before may no longer be in business or may have retired. Having that information that you can give someone new, is vital to being able to solve your problem quickly and the least expensive way, and also help them understand what the causes might be. So being proactive, the bottom line is, being proactive could save you significant time and money, and it's really worth your while. It's also really worth your while to understand your well log if you have one, or to find your well log so that you do understand where your water is coming from and all those things. We may get into that here. So for best practices, you should use a licensed driller, pump installer, and contractor. They know what they're doing. They're familiar with the groundwater and geology of your area, and they are required by law and nearly every state to meet a certain set of practices and code. And that will ensure that what you're getting is a good product if you have work done on your well, or if you're installing a new well. Inspect your wellhead at least annually. The story I usually use, I grew up on a farm in the country, and I know we didn't have a well in our yard, but I know a number of people who do. When I was a teenager and I was mowing our yard with a riding lawnmower, it would have been nothing for me to hit our wellhead and not say anything. And so things can happen, especially on a farm. A tractor or other things might nudge it by accident or whatever. It's best to inspect it at least annually. Make sure that it hasn't sunk. Sometimes if you're pumping sand, for instance, you're taking formation, the ground actually away from around the well, and it's going inside the well. You can actually have your whole well sink a little bit. That's important to know. It can cause pressure in your lines. Bowing of your water line eventually snap something, those sorts of things. Your wellhead has a vent tube that should have a screen on it, and if you find that your screen is gone, that's an open source for mice or other kinds of insects or small rodents to get in your well. I can't tell you how many times that we've sampled, usually a Duggar bored well, where we've opened up the lid and there's a dead animal in it, and people are drinking that water. And they knew something was wrong but didn't know what it was. You're talking about all kinds of health issues there, let alone taste and some of those things. And for folks with a bored or with a drilled well that's sand and gravel or bedrock with a proper well cap, those things can be avoided. So, and again, for the same reasons, you should keep the area clear of debris. Your well should be in an open area where a contractor can easily get to it to pull the pump if something goes wrong. If you are using any kind of chemicals or putting a hose in any kind of tank for even small things like spraying your garden, you should use a backflow device or a vacuum breaker, which is what goes on a spigot outside your house to keep any chance of backflow from happening. So whenever a pump kicks off, sometimes water will flow back through the line, and if you have a hose that's in a tank at the same time, that can cause backflow into your water line, and then it could end up in your kitchen or anything else. So properly maintain your septic system. I'm going to talk a little bit more about septic systems in a minute, but it's really important to understand that that's your wastewater treatment system. You can't put some things in it. You can't. You need to make sure that it's working properly and your septic field's working properly. And there's a maintenance schedule based on the size of that septic system that you really need to follow. If you don't and just let it go, eventually it'll stop working, and you'll have either a backup in your basement or one of your toilets, or possibly you'll have a nice wet area where you're above where your septic tank is buried, because all your waste is coming up out of your septic tank and seeping in the ground around that. And that's a very miserable, smelly problem. Now, considering installing an access port for measuring water levels. This is, as a groundwater scientist who measures water levels in wells and looks at water quantity issues related to aquifers, we always want an easy opportunity to measure water level. But you as a well owner, I know in Oregon they require now new wells to have an access port, and it's basically a half-inch vent tube that goes all the way down your well so you can measure water level. It's a great idea in my opinion. It's certainly not something that you have to do, but what it does is it allows you to, you can take a water level measurement once a year, or if you're having a problem with your well, the first thing you're going to do is look and see if possibly there's a water issue as far as maybe your water level's been drawn down. I know here in Illinois we have wells that get impacted by irrigation, and when that happens, somebody's well goes dry per se, or it stops working. The first thing we do is take a water level measurement to try to determine if there's still enough water in their well, if there's water over the pump. And so it's a handy way to eliminate possible problems when all of a sudden your well isn't working like it's supposed to. And lastly, you should sample your well annually, which is just common sense. So when to sample? Well, annually as a general rule, and typically you sample for coliform bacteria and nitrate. And the reason we sample for those things is because they're an indicator. If you have bacteria in your well, coliform bacteria, that indicates that there's a possible opening somewhere in your well, either in the casing or in the lid or the protective cap that allows something to get in your well. And the same for nitrate. It's a good indicator. It's cheap to test for. And so you should sample to make sure that there's been no changes in those things. There's also a list of things, I believe it's listed here. If not, it's in the lessons on things you should sample for initially and maybe every 5 years, just to make sure your water quality hasn't changed. Groundwater flows slow enough that, given everything else being equal, unless there's a contamination issue or there's been some big change like a high-capacity well going in nearby, your groundwater quality and chemistry shouldn't change dramatically over time. And that's why if you test for coliform and nitrate, if there's been a change, then you can start investigating what might have happened. So anytime the well's serviced or repaired, anytime your well cap is opened, there's a chance to introduce problems. Anytime then, if you notice any changes, taste, color, odor, if you've had to disinfect or chlorinate your well, then obviously you've had a problem, and you should check it again to make sure that it's still safe. If there's a recurring illness, someone is pregnant or a new infant, everyone's heard of blue baby disease or blue baby syndrome. It's basically the nitrate. A baby that's less than 6 to 9 months old doesn't have the chemistry in their body to break down nitrate completely like adults do. So we can drink water with nitrate in it, and it's not necessarily a problem, although there's some studies now that suggest that high levels of nitrate may cause some other things. Generally, nitrate is a problem for pregnant mothers and babies because instead of breaking the nitrate all the way down, it converts to nitrite, which binds with the hemoglobin in your blood and basically can suffocate you because it doesn't leave any place for the oxygen to bind. And that's why it's called blue baby disease or blue baby syndrome, because it basically takes the ability of your body to use oxygen away. And the last case is if, the neighbor who has a water quality problem, something's been identified, in one of the counties in Illinois, there was about 20 years ago, someone had their well sampled. Well, actually, a better example, just south of where we are in Champaign-Urbana, Illinois, a well owner had their water tested at the water survey, and their arsenic was 150 parts per billion, which the standard for a community water supply is 10. And no one realized that there was a high arsenic problem in that area. So the water survey went out and sampled about 30 wells, I think, in that area, and they found a number of wells that have high arsenic. And it's just, in that case, arsenic's naturally occurring. It's the 7th most common element in the Earth's crust. And in some areas, the aquifers just have arsenic there. A lot of times it's in the form of a pyrite, which is an iron pyrite that has arsenic on it, basically. And in those cases, it kind of depends on the bacteria and the reducing conditions and the chemistry of the water on whether it's released or it stays bound to that mineral. Okay, so what to sample for? Initially, coliform bacteria, nitrate, pH and hardness, and then you'd also want to talk to your local health department or your state Department of Health and ask them, I live in this area, is there anything else I should be concerned with? You should also check on their websites. I know, I believe it's Rhode Island, has a really neat website where they target areas where they know there's certain constituents that might be a concern, and they basically say if you live in this area, you should test for arsenic, or I believe one of them is beryllium, which I don't even know what beryllium does to you, but it's a regulated contaminant and it's naturally occurring. As far as a dug well goes, you should sample, especially if you're new to a dug well, you bought a property, it's got a dug or bored well on it. I would sample once every several months, at least initially, to be sure that you don't have a problem. They're more susceptible to surface contamination, and if they're not sealed properly, to coliform bacteria, and it's just a good idea, and it'll give you peace of mind. So, yeah, and the last thing here, our lab, if you have any kind of treatment, including a softener, or even a sand filter or whatever type of physical or mechanical or chemical treatment you might have on your system, it's good to collect 2 sets of samples. One at a raw tap, maybe an outside spigot that's before the treatment, and a second set that's at the treated tap. Like, for instance, if you have RO, reverse osmosis treatment, a small system on your kitchen tap for drinking waters, a lot of folks do that. You should collect a raw and one after the RO and send both samples in for analysis. And when I say they provide interesting information, one of the things I did when our lab, this has been probably 12 years ago, but our lab bought a new detector for arsenic, and it gave us the capability of going, instead of down to about 20 ppb, back then the standard was 50, down to 0.5 ppb, which now the standard's 10. So our public service lab gets about, between 60 and 100 samples a month from well owners in Illinois. So I took all the data from about 6 months of samples where someone had provided both raw and treated samples, and for those that used a softener, which a softener is meant to soften your water, not do anything else, but it turns out in some cases it also removes arsenic. And what we found was that on average, the water in, say, the 11 counties around Champaign-Urbana, we had about 100 samples, I believe, and the average reduction in arsenic between the raw and the softened water was 42%. In some cases, it was zero change. In some cases, it was almost nearly 100%. And so knowing that difference and what your issues might be will help you understand your conditions of your water and how your treatment might be affecting things. Okay, abandoned wells. This is a best practice. Now, well logs weren't always required to be filed with the state or with a county. In Illinois, the way the process works is when a driller drills a well, he's required by law, he's licensed to turn in a well log to the county health department. They, in turn, give those logs, a copy of those logs, to the State Water Survey, where we maintain a repository for the whole state. So we have probably 400 to 500,000 well logs in our files of wells that have been drilled in Illinois. Now, the problem is that law wasn't required in some areas until the 80s. In Illinois, it was 1964, I believe. But in some states, I know like Nebraska, it was in the early 80s until they passed that law, I think. And I might be getting my state wrong, so don't quote me on that. But many states, it wasn't until after that where they required that to happen. And so in some states, there are many more undocumented wells than there are documented wells, meaning we don't have a record that there was ever a well drilled. And as a state agency, we don't know that. And you may buy a property or have a property where you don't even know what that, if there's another well on there. So like well pits, an abandoned well is a hazard. Those of you remember that are old enough, back in the early 80s, I believe, baby Jessica got caught in a well in Texas, and it took 18 hours to get her out, and it made national news. It was broadcast on CNN Live for 18 hours or whatever. But it's a real problem, and people die regularly, which I am going to show you some pictures here. Yeah. Now, all these newspaper clippings are from Illinois, and they were put together by a guy named Harry Hendrickson back in the 90s, and I just happen to have a copy of this from him. He used to be the groundwater education coordinator for Illinois, and he was a champion of promoting sealing abandoned wells. And you can see here, again from Washington State, they have a blog where they have a lot of really great information about water quality and well issues. A man fell 45 feet into the well. Luckily, he survived. Here's another example above where a horse fell in the well. It's an old abandoned well that no one paid attention to. And folks, again, can die in an old open well, and so they should be properly sealed. So if you know, I guess the message here is if you know that you have an abandoned well, it can be expensive to seal, but it's important that you do so, not only for safety's sake or to protect livestock or your family, but also for protecting the aquifer. If it's a well that's a large diameter well that it actually taps into the aquifer you're using, if it's open, anything can come in and fall in, or anything can be dumped in it. It can be a source of contamination. And, out of sight, out of mind, sometimes people dump things and don't realize what they've just done is maybe contaminated the water supply for a whole subdivision of people or more. And so it's important to understand the issues with abandoned wells and to seal them when you can. Okay, septic systems. They really have to be managed just like your water system. They have a lifespan. They will eventually fail, but if you manage it properly, they can last longer than even than what they may be listed as how long they should last. They have to be pumped out on a regular schedule. There are just things that get into your septic system that won't go into your septic field. Eventually your septic system and your septic tank will fill up, and that has to be taken care of. It's an expense, just like if you lived in a community, you have either something added onto your water bill or you have a separate sewage bill, and that's to cover the cost of wastewater treatment and removing the wastewater from your home. You have a cost by having a septic system, and that you need to maintain it, or it can really cost you much more down the road. So there are simple things like don't put toxics down your drain. If you have a septic system, it's really a natural wastewater remediation system. Whenever all the waste from your home goes into a septic system, it goes out into the septic field where natural bacteria can break it down, and it can be absorbed into the environment again. And that's a natural process. And if you add toxics or other things to your septic system, you can kill the bacteria that are in your septic tank. It removes the ability to take care of those things, and it can affect your drain field. The last thing here is it's illegal to run to a stream or a field tile. You find a lot of really old septic systems where they do run out to a field tile instead of having a drain field. And those really should be fixed, and it should be installed properly. Find a wastewater or septic contractor who can take care of that for you. And if you don't know, ask. Your county health department, again, is a good source of information for that. I know along a lot of rivers and streams, septic lines run right to the stream. The US EPA, I believe the law just passed in January that requires you, a community wastewater system to discharge water from a wastewater treatment plant. They have to have a permit, and there's certain groundwater quality constraints that they have to meet. So it can't have any more of some constituent like chloride, no more than so much of whatever, iron, all those things. They just passed a law that for every septic system, if it discharges directly into a stream, it also has to have one of those permits. Now, the likelihood of them being able to enforce that, especially nationally, is very slim. But depending on your county or your state, they may, trying to protect a pristine river, for instance, some of those things can happen. So if you don't use a septic field but have a septic line that runs straight to a stream, you should find out what the rules are and consider improving that system and making it proper and legal. Here's, on the left is a septic tank. On the left, the inlet pipe, the waste comes in. There's the solids fall to the bottom. The scum is the stuff that floats on top. You usually have a filter on your outlet pipe, and it runs to a drain field. And there's a riser, and it shows the 21-inch access port. That's for pumping out your septic tank. And this is how it would work normally. The system is in balance. More water runs out as it fills up, runs into the septic field. And here there's two different examples. One's a trench design, one's a bed design. And there's usually sand underneath that. It allows everything to dissipate and bacteria to grow and break down all those materials. And so this is a proper construction. This is how it works. And the whole point here is when you add solids, or if you put things down your system that don't belong, I don't know, I can't think of a good example offhand, but they can clog things up or get in here and make this all not function properly. So you really need to be careful if you have a septic tank and a septic field on how you manage that. And if you have, some kind of cleaners or solvents or paint thinner or anything that you don't want, talk to your county health department or your state department of natural resources or some similar group and find out if they have collection days for those materials, because these days most states or counties have collection and pickup times for a lot of those things because they don't want them in the environment and or just to be dumped somewhere. And so there's a large push to take care of all those sorts of discarded materials. Okay, so for emergencies, most people don't realize how important their water is until they don't have it. Where that's going, that's an understatement. If you've ever went without, you've had some kind of power outage, or it's the middle of winter and you're without power for several days, the thing you miss the most usually is the water. And going without's rough. And I grew up on a farm on a hand-dug well, and I know one year we had an ice storm, and we were without power for 7 days. And it's a miserable way to, you can't get out anywhere, you have no electricity, and all those sorts of things. As far as wells going dry, in the Midwest anyway, last year we had a drought. We had a number of complaints about wells going dry, or, again, irrigators pumping and lowering water levels in an aquifer such that a private well was impacted. And so you need to, if you have a choice, you want to have a well that's deep in an aquifer, your pump set deep enough and all those things. And if you have to drill a new well, do the legwork in advance to find out what the best situation is for you. In some cases you don't have a choice. For the southern third of Illinois, none of the groundwater is really potable. It's all very salty. It's bedrock water that was seawater. And so any wells in that area are usually hand-dug wells that are shallow and they're collecting water from near the surface. That's not the best situation, but it's the only source they have. Okay, so other emergencies to be concerned about. In some areas of the country, forest fires. If you've been involved with a forest fire or it came near your home, check all your wires, run your water, have it sampled. Sometimes it can even have a smoky taste. And just be sure that it's probably good to even have it sampled, just to be sure that nothing in the surrounding area has affected your water system. And if you're prone to lose power, like we were when I was growing up, then you need to have a generator, which we did after that ice storm, actually. Finally convinced my father that we needed to have a generator. In some areas of the country, generators are very common in rural areas, and some areas they're not at all. I had someone actually email us and ask, if I lose power, how can I get my pump to work in my well? Well, if it's an electric pump, which they are, it's not gonna. And unless you have a generator and a way to get power, then an alternative may be a hand pump connected to your well for just a small supply of water, like a bucket full or whatever. But even that isn't the best situation, obviously. Okay, the last thing, I think the last thing I want to talk about are citizens groups. And, depending on where you stand as far as being environmentalist or where you fall down that road, you look at citizens groups in different ways, but citizens groups can take all kinds of shapes and sizes. They can be concerned homeowners in an area where an industrial thing has gone in, or where there's been a spill near a railroad track. A group forms to try to help get that cleaned up. They usually start with a focus, and a lot of times they're volunteers, but in some cases, they develop into a group that actually provides a lot of educational outreach to well owners, things like that. We're interested in. What I'm interested in is that every well owner really understands where their water comes from, how their well works, and what things they need to do to make sure that their water is safe to drink. And a lot of times these citizens groups can help facilitate some of those things. And that's where a county health department or co-op extension office also can join in and become that expert for a group or facilitate meetings, provide a location for certain things. And, information is power. There's no doubt about that. And I don't know how many times we've done work where someone was concerned that, let's say that we're drilling a monitoring well so that we can collect water quality samples. They see our drill rig out there and assume we're doing something that's going to harm the aquifer or threaten their water supply. And so they question everything about it. And so being able to, if they're willing to come and ask us, that's a positive as far as understanding what's really going on, what solutions there might be, and those sorts of things. So they can be a powerful voice. And there's several examples of citizens groups that have developed into these broad-based grassroots efforts that, they work with the county health department to hold sampling events. They have pharmaceutical take-back days. They do things that really benefit, so that pills and a lot of drugs that people have to take that have expired, and rather than dumping down their drain or throwing in a landfill, they're properly taken back and they're disposed of and incinerated in a proper way. And so it is important, and they are useful. Here's an example. One man trying to get the word out. This guy is in Florida, and he writes a lot of information about the vulnerability of the water resources there. They have issues like saltwater intrusion. So the more they pump their fresh water and lower the water table, the less pressure is on that system, and that allows salt water to intrude more. Water is driven by pressure. It moves downhill. And so it's all about how to protect their resource for both human consumption and the ecology of their environment. The BACOG, Barrington Area Council of Governments, this is in Illinois. This is one of the groups that I basically was just talking about. They started as a grassroots organization of 7 communities in the Barrington area, which is west of Chicago. They started to protect the wetlands that are up there, but they've developed into, they get funding now from the communities themselves, and they've developed a groundwater handbook for their area. They hold pharmaceutical take-back events. Every year in March, the National Groundwater Association has Groundwater Awareness Week, and they hold events in conjunction with that. This last March, they had 2 of the health departments up there, 2 different counties, who provided sampling for any well owner that wanted to bring in a sample. A lot of positive things, and this is actually from their, I guess this is from their March event. So it's really handy. It's local. The folks in the area all trust more local stewards in that respect. This is an interesting, another organization. It's the Water Resources Education Network, but it's a program that is from a committee for the League of Women Voters in Pennsylvania. Their Citizen Education Fund started a number of years ago. They developed this newsletter. They started putting information out about source water protection, rain barrels, all those sorts of things. I find more useful information in this newsletter because they provide information. For instance, the Co-op Extension Office in Pennsylvania at Penn State University, the guy who runs their private well program is very active. They have a Pennsylvania well owner network where a well owner can go in and spend 2 days at a workshop to learn more about being a steward of their well and then train other well owners about that. It's a great program. And some of the funding that he's gotten to go sampling in certain counties, it's all been promoted in this newsletter. It's an electronic newsletter. It comes out once a month, and you should look it up. There's a lot of cool stuff in here, at least from my perspective. So for getting local help, again, I mentioned early on that we certainly promote that. So the class and the webinars that go along here, they're meant to motivate you as a well owner so that you'll take the time to understand your well better and how the process works and the science behind water flow and all those different things. But we can't give you some of the local answers. I understand most of the aquifers in Illinois, honestly, because I've been doing this for a long time, but I don't know much about the aquifers in other states. A lot of things are similar about groundwater flow, but water chemistry can be different. The source of the water can be different, and a lot of times your local health department or even Co-op Extension or your state Department of Natural Resources, State Geological Survey, those sorts of groups, they know your regulations, your local conditions, and can guide you where to get help on different things. And so, including your contractor. If you have a well contractor that you use and you're comfortable with and you trust, that's a great spot to be in. And all these different groups are willing to help, mandated by state law to help you. If someone calls me at the water survey, a well owner, and I get a lot of those calls, I can look up their information in our database. I can tell them, for instance, someone says, hey, I just bought property in Champaign County. It's at this location. I need to drill a well. I'm going to build a house. What can I expect? And how deep am I going to have to drill? And, all those sorts of things. I can look up all the other well logs, and I can look up all the water chemistry information from our public service lab, and I can tell them, hey, the well, the next house a quarter mile south of your property, they have a 160-foot well. It's in the Glassford Aquifer, and it's really high in iron. You're going to want to treat for that, but otherwise it's very good water, those sorts of things. And in most states, you've got those sorts of folks available, and so you should use them. Financial assistance. As it says here, there are programs in some jurisdictions that provide loans or grants. A lot of times those are for low-income folks, and so they're income dependent, and so it may not help you if you aren't financially, if you have a financial wherewithal to take care of things they expect you to. The National Groundwater Association has a resource page, which I think I'll show here in a second, but you should contact your county and your state or territory to find out the agencies that serve private wells or even public water systems. Some of the folks that regulate even public water systems know where there are grants available or low-income loans or maybe for certain programs. Like, for instance, in Iowa, the state mandates a certain amount of money every year for their county health departments to, one, give people a break on the costs of sampling or having their water analyzed, and two, it's a matching program, I believe, for sealing abandoned wells. And talking to the guy in Iowa earlier this year, last year in 2012, through that program, they sealed over 3,000 private wells that are no longer in use. And, that's a great thing. And so depending on what your issue is, there may be resources available to help you take care of that thing, whether that's an improvement to your well. If you have a well that's in a pit, for instance, there are programs that you can go to through maybe RCAP or National Groundwater Association that might be able to help you fund improving that well because it's considered a safety risk. Here's the page on wellowner.org. It's easy enough to find if you just go to wellowner.org. And again, this is a program from the National Groundwater Association, and it's under Finding a Contractor, I believe, and then there's a financing tab. And so they list organizations that have low-interest loans or grants, and some of this is funded through USDA, and it changes. It may be that RCAP in certain areas in the country received a grant from USDA so that for these 2 years or 3 years, anybody in these specific areas of the country can get a grant or a loan for improving their well. And a couple of years later, it's a different grant and it goes to a different area. And so you just kind of need to check. And if anybody has questions about this, you can certainly email us, and I can send you these links if you're not in a position to write this down now. But yeah, and on this page it lists there right underneath the home picture, learn how to apply, visit rural development, USDA.gov, and there's a map there that shows you where these programs are currently. Okay, so that's all I have for tonight. I appreciate everyone being here, and we're going to take a 5-minute break so that we can see what questions folks have asked. Hopefully somebody's asked some questions. If not, that's fine. But if you've got questions, now's your chance, and we'll try to bring those up in a few minutes and go from there. So it is 9:06 according to my clock, and so let's come back at 9:10 and we'll see what questions might be there. All right, for those of you that are still here, thank you. We have 2 questions. The first is, if you have a pressure issue, would you notice that spurting at all faucets, or is having it occur at only one faucet something that would merit further investigation? Well, a pressure issue isn't going to cause spurting. If you have spurting, that means there's air in the line. And so that either means that you have, for instance, some kind of gas that's in the water that whenever you bring it up out of the ground, that lowers the pressure on the water and allows the air to come out of solution, or the gas. So a lot of times when you have methane in water, you can pump it up out of the ground and it's just water, but then when by the time it comes out your tap, it's spurting gas. And that's because it's the pressure that the water's under in the ground that keeps it in solution. And so a pressure issue won't it won't show up as a spurting issue typically, unless, again, your pump is pumping air. And I guess it's not really a pressure issue, it's an issue of your water levels dropped below the intake on your pump. So if you have spurting, you should turn things off and go out and check your pump and see if it's running, and try to find out exactly what your issue is. Maybe call a contractor and they can tell you if it's a methane issue or some other gas issue in your water versus maybe you don't have enough water in your well, those sorts of things. And the second question, what is a field tile? For row crops or corn, soybeans, anywhere where you like in Illinois and farming country in the Midwest, a lot of fields have been tiled. It's basically a corrugated or old clay field tile. Is a pipe that's perforated, that's usually about 4 feet underground, and it runs through a field and usually outlets to a ditch. And the whole point of a field tile is to help drain the field in the spring so that the soil dries out quicker and will allow you to get in the field and plant your crops. And certainly in low areas, what you see today is if there's a low spot in a field, they may put a pipe in and run a field tile to an outlet like a ditch so that that low area will dry up faster. And so, yeah, that's really what a field tile is. And so some old septic systems, they may have just hooked to a field tile, and so they let the field tile, most of the year that tile's dry. And so as your septic discharges to a field tile, it runs out into the field and disperses that way. And it's, in some ways it's similar to a distribution field but it's not contained. It has an open end on the other end in most cases. And those, over time, the field tile can get plugged with some of the material that comes through your septic. And so eventually it can be a hazard. It could be act like a solid pipe that runs to a ditch somewhere. So there's another question. I tried searching your database for my property's well information and wasn't able to find it. What are my next steps? I did request a well log from Lake County in a FOIA request, waiting to see if they send me anything. Well, for Illinois, which you're in Lake County in Illinois, then what you can do is call me during work hours or send an email to us with your legal description. When a driller files a log, they list it by tier, range, section, and usually subsection or 10-acre plot. In some cases now, probably Lake County, because it's a fairly progressive county, they also list coordinates, either lat long or GPS coordinates, something like that. Given the beauty of Google Earth and Google Maps, if you send me your address, I can look that up and determine what the legal description is if you don't know it. And from that, I can look in our database and see if I can find your log. Now, a lot of areas up in the Chicago area, there's wells that are 100 years old. I just had a well owner contact me who bought a property that's in Cook County in an unincorporated area. They're looking for the well log. Well, the house is over 100 years old, and the well probably is as well. There won't be a log for that. And unfortunately, that's just the way it is. In a number of cases, if it's an older well, there won't be a log because the drillers weren't required to file a log. And so the thing to do is, if you know the year your well was drilled or any other information, who the previous landowner was, any of those things might help us find it. And so sometimes when drillers file logs, they make mistakes, like they may put Section 2 instead of Section 3. And so if I look in Section 3, I'm not going to find it because we have it filed in Section 2. But if we know who the owner was and I search that way, or by some other pertinent fact, like if you know the exact depth sometimes we can find it and we find out that the driller made a mistake and we can correct the log. So it kind of depends on how old your well is, but if it's from the 80s or later, in many cases we have those logs, and if we don't, yeah, we should. But your county, depending on how the county files your logs, should have that record too. A lot of times they keep them as just paper records, and so it'd be really hard for them to find that, or we've developed an electronic system, and so usually the counties call us when they're looking for information as well. So, all right. But again, just email me. If you're in Illinois, that's part of my job, is to help you find your well log. So, and as far as that goes, anybody else on the call, I can certainly help you find the right person in your state who might be able to help you find your log if you don't have it. So, well, that's all we have for tonight, and I appreciate everyone's time with that. I'm going to end the webinar, and thank you again.